Hello friends, today we are discussing about the plasma arc machining in which we see the different points such as the principle, introduction, then process details, electrode materials, what are the types of electrode materials used in the plasma arc machining, and then setup of the process, which type of the elements consist in the plasma arc machining, then process parameters used in the plasma arc machining. Here is the two types of the plasma arc machining, and then the advantages, disadvantages and applications of the plasma arc machining. So we start from the introduction. In introduction, the plasma arc machining is the method of cutting metal with a plasma arc or the tungsten inert gas arc torch. The torque produces a high velocity jet of high temperature ionized gas that cuts by melting and displacing material from the workpiece. Next one point is that the process details. When the supply is made on, a strong arc struck between the electrode and the gas is forced into the chamber. When the gas molecules collides with the high velocity electrons of the arc, the plasma is formed. This plasma is forced through the nozzle, which is the anode, onto the workpiece. The heat produced from this jet of the plasma is sufficient to raise the workpiece temperature above its melting point and blows molten metal away. Here the electrode material used is tungsten and the plasma nozzle is made up of the copper material. Then we are moving towards the principle of the plasma arc machining, in which when a high velocity jet of plasma is directed on the workpiece surface by means of plasma arc cutting torch, the metal from the workpiece melts, which results into the machining of the workpiece. The continuous attack of electrons on the workpiece, which transfer the heat energy of plasma on the workpiece, causes the workpiece to melt. This is the schematic of the plasma arc machining, in which normally we use the DC power supply. Here is the plasma arc of the high velocity is generated, which strike on the workpiece and which machine the surface of the workpiece. Then we see the setup of the process, in which the plasma cutting torch is used, then the tool and workpiece, then gas supply unit, then cooling system and the power supply is provided. Next is the process parameters, in which the current ranges from 500 ampere to 1000 ampere. Voltage is of direct current 30 volt to 400 volt. In cutting speed ranges from 0.1 to 7.5 meter per minute. Plate thickness is up to 200 mm, which can be machined by the plasma arc machining. Power requirement is high, which is 2 to 200 kilowatt. The MRR is 150 centimeter cubic per minute. There are the two types of plasma arc machining, in which first is air plasma arc cutting and underwater plasma arc cutting. Here the schematics of air plasma arc cutting and underwater plasma arc cutting are shown. In air plasma arc cutting, the oxygen in the air provides additional energy from the exothermic reaction with molten steel, boosting cutting speed about 20%. Process can also be used to cut the stainless steel and aluminium. The cut surface will be heavily oxidized and thus can be unacceptable for some applications. In underwater plasma arc cutting, the underwater plasma arc cutting is suited to numerically shape cutting and produces a noise level of 85 dB or less under normal operating conditions. Underwater cutting also nearly eliminates ultraviolet radiation and fumes. Steel plate being cut is supported on a cutting table with the top surface of the plate 2 to 3 inches underwater. This is the plasma arc machining demonstration. Normally in the workshop, the machine shows like this. Then the advantages of the plasma arc machining. The rate of cutting is high. Very hard and brittle materials can be machined, such as the carbides. Can cut the non-conducting materials like concrete. Small cavities can be machined. Good dimensional accuracy is achieved in the plasma arc machining. Here are some disadvantages of the plasma arc machining. Protection of noise is necessary. Second one, high initial cost of the equipment. Then safety precautions are necessary. Heat affected zone is more. Excessive heating imposes limitations to this process. Uneconomical for bigger cavities to be machined. Then the applications of the plasma arc machining. Used for struck cutting, plate beveling, shape cutting and piercing, welding of stainless steel, nuclear submarine pipe system in tube mill applications, welding of cryogenic aerospace and high temperature corrosion resistance alloys, welding steel rocket motor case and welding titanium plates up to the 8 mm thickness. So thank you. This is about the plasma arc machining.